World Labs just launched an application, Marble. World Labs is a company founded by FeiFei Li, Justin Johnson, and others who are pioneers in computer vision, computer graphics, and now 3D modeling. Now, the fundamental problem that they're trying to solve is to go from 2D to 3D. So from 1D to 2D to 3D to 4D. I'm going to parse this, try to explain it. There's an interview that they gave at A16Z. A16Z is an investor, so they're promoting, of course, the company. And the reason I want to talk about this is for actually several reasons. One is it's always interesting to see what leading researchers in computer vision are doing. I think computer vision has been the sort of the workhorse of AI in the last 10 years, starting with ImageNet and then developing into where we are today. And if you look at some of the most relevant applications of AI, such as, for example, self-driving or autonomous spacecraft technology, drone technology, a lot of technology, actually the most interesting technology out there is all based on computer vision. And just famously, the Tesla FSD, which has been controversial relative to other approaches such as the Waymo approach, which is the Frankenstein approach. Tesla has been based on vision. So a lot of the interesting AI, real-world AI, to be clear, is based on computer vision. Now, FeiFei Li and her founders, they want to go to the next step. FeiFei calls them, they call themselves a deep tech company because this is a difficult problem to solve. So what you're trying to do is create world models, large world models, LWMs, where you can start with a prompt, maybe a text prompt or an image prompt, so a true multimodal model that then generates 3D spaces. Now, they are perceived in vision, so through video, or maybe at some point in a 3D representation like an Oculus or something. But the point is, and this is the key of World Labs, that the underlying representation of the data is in 3D. So techniques like Gaussian splatting or some formal, some derivatives of nerves. So taking 3D as the native representation of the data, which is very different than what large language models are. Even multimodal large language models, they always flatten out everything into 1D because it's about tokens and next token prediction. And whether you take text, video, or whatever, it's always flattened out into 1D. That's not what large world models do. In the case of World Labs, they're representing data in 3D. So this is I would say this is the first interesting tidbit here. The second one is affordances. So it's not just what you see, it's also what can be done. So this goes into counterfactuals. This goes into the fundamental problem of robotics, which is, of course, our key, and this is what we're talking about this year at Launch Capital Partners. We started a series a while ago, Foundation Models for Real-World AI. And we talked about this in the context of CVPR, of NeurIPS, and I think this is the culmination. I mean, some of the leading researchers in AI starting a company to actually do that, a foundation model for real-world AI, because this is what this is. It's going to get different names: 3D modeling, 2D to 3D, 3D to 4D, world model. We just came back from China. People at Baidu and Pony AI, the self-driving leaders in China, they talk about world models. So world models are definitely sort of the thing du jour right now in AI, because it's the bridge towards real-world AI, which is probably the next decade or so of AI is going to be driven by real-world AI, by robotics, self-driving cars, aerial vehicles, drones. Warfare is going to change. So real-world AI is definitely going to change our world for the good, I think, because that's when the real impact comes. And I think world models is one attempt to do it, because quite simply, once you have a world model that is a true high fidelity native 3D representation of the world, you can train robots in virtual space. And this is something that Jensen Huang's been talking about. It's something that Elon Musk's been talking about. And I think these people around FeiFei Li and Justin Johnson actually want to implement. This is not even on podcast. It's November 13, 2025. This is Krimdelko. For the day, we're down 7%. The market is down 2%. For the year, we are up 9%. The market is up 15%. We're underperforming by 6%. Large drawdown today. Quite frankly, I haven't been able to dissect what is going on with the market. I think Tesla is taking a hit. The sales numbers for October were not very good. In fact, they were pretty bad, more disappointing than expected. I think we have to brace ourselves for more competition in China. We spoke about this in our China discussion. I think the good, the better, and the ugly. The ugly is the overcapacity in China and the large competition. That's going to hurt us for a while, and I think this is manifesting itself now in the sell-off in the stock. We also have generally maybe a bit of a slow ramp of robotaxi. I would say we're a bit disappointed about the speed of the ramp. We live here in the Bay Area, we're using it quite a bit, but it's not as prevalent as we thought it should be. It's a phenomenal service, it's well priced, but we don't see that many of those things driving around. So there's a bit of that, but I think fundamentally, if we look at the positives, version 14 of FSD is phenomenal. The cars are phenomenal. We have a very good, I think, case now after a China trip where Tesla is the native Chinese company with a global reach in software and a manufacturing lead relative to anybody else except the Chinese, but they don't have the global reach in software. So we're the only company that have, Chinese manufacturing and Chinese market prowess combined with Silicon Valley software, global software prowess. So and those two are a very unique unfair advantage of Tesla. But back to the conversation. So World Labs launches Marble. I think it's a great endeavor by FeiFei Li and others. And when I'm going to use her name now just to make it simpler. I don't want to offend anybody, and I don't think it's fair. She will be the first probably to admit that she's not the only driver here. But again, just to be clear, it's FeiFei Li and others. World Labs is the company. It's founded here in Silicon Valley. And the idea is to build a 3D representation of the world, a true native 3D representation of the world. So use Gaussian splats and other techniques to represent the data in the 3D world, and therefore also offer affordances that are real. In other words, when you see a chair, the chair actually is sittable. You can sit on that chair. You can, when you see a glass, when you hold the glass, the affordance of that glass is that it can be dropped on the floor and it can be splashed. So these things are embedded in a real 3D representation and also in physics. Now, how exactly they do it, that is, I think, beyond this podcast here. We're not a technical podcast. The purpose of the Not Even Known podcast is to give people a sense of what it feels like to run a hedge fund. And what we're doing here is talking about a real deep tech technology that is hopefully going to change the way robotics, and this is what our interest lies in, is in robotics, real world AI. And in order to train robots, we need a real world representation. We need some sort of 3D representation of the world, a representation that actually is with high fidelity representing what's going on in the real world. Like FeiFei says in the interview, links in the show notes, the interface of robotics is the real world. The interface of robots is the real world. So how do you train a robot in the real world? Well, you can have a robot training in the real world, but that's very difficult. People have tried, imitation learning, teleoperation, all of these things. Tesla has trained FSD on video data, on actual driving video data, which has worked really well because you have the combination of images and actuators, but you don't have that for almost any other task in the real world. You don't have video data where, let's say, a barista is making coffee at Starbucks, and you have at the same time actuators like tendons and muscles moving, and how that translates into actual movement. You don't have that data. Now you can infer that data, and I think that's partly what World Labs is trying to do in their way. So you have the world model, which is representing the real world, and now you can have a robot train itself in the real world, and then you can gather the actuator data through the training. Maybe as a side note, this is something that I've been thinking about recently, so let me put this out here in the context of World Labs. In order to succeed in real-world AI, you need three fundamental blocks. One is you need the AI, so you need the actual planning algorithm, for example, Q-learning or some derivative of Q-learning, which I think is a problem that is pretty well, I wouldn't say it's solved, nothing is solved in AI, but it's a problem that is maybe not on top of everybody's head right now, because we have good solutions for that. Then you need the world model. So you need some sort of virtual representation of the real world in order to train in that world. And thirdly, you need an evaluation. So let's assume you have a Q-learning, let's just for simplicity use Q-learning. So you have an algorithm that looks at possible trajectories, it looks at counterfactuals, and looks at the values that each counterfactual gives the algorithm, and then makes a decision. That's Q-learning. You have a world model, so you have a place in which you can train, but now you need an evaluation. Those values, in Q-learning, you're gathering values, you're discounting values. Somehow, somebody has to decide what is a good action. In many cases, maybe that's not so hard to do, but we still have to kind of define what is a good action. This brings up the problem of supervised learning versus unsupervised learning. Somebody has to decide what is a good action. You can automate this, but even if you can automate this, the problem is to actually decide what is a good action, right? And this has been actually very interesting in self-driving, right? The reason Tesla is where it is right now with FSD is because they have an evaluation for driving, and that is human driving. So Tesla is kind of solving the Turing test for driving by just simply imitating human driving. That's why the Tesla drives like a human. It feels like a human. Everybody who's been in FSD, 14 and plus, and even us with the 12.6 on hardware 3, it feels human. You don't realize anymore after a while that you're being driven by a car. Now, that's because the evaluation of the Tesla FSD has been done on human driving. So the point here is that we have a definition of what is good driving, and that is sort of an average out of human driving. But we don't have that for many other tasks. And I think, World Labs is not necessarily solving that problem, but it's certainly a path towards solving it. Again, you need those three things. You need a world model, you need an evaluation function, and you need a planning algorithm. Those three elements are partially in place. Maybe the planning algorithm is maybe the most in place right now, and then we have the world model, which FeiFei Li and others are working on, and then we have the evaluation, which I think is certainly a lot of labs are working on. That's also something that I think academia can really work on, because there's algorithmic work you can do, there's also empirical work you can do, but those are kind of the three elements that are needed. So to summarize, I think World Labs is a very interesting endeavor. We're very excited about this. We're not investors, and I'm not sure how this actually translates into a business, but fundamentally it's a great thing, and it gets us to the point, like Elon Musk said back in May, that we want to be able to train from video, right? Now, whether that video is from YouTube or whether that video is generated in a World Lab type virtual world, it's fundamentally what's important is that a robot can act in virtual space through many counterfactuals and have real world experiences that can be translated into some sort of Q-learning model, so it can then learn how to act. And then we have the sim to real transfer, which they haven't really spoken about in this interview, but that's of course also a problem that needs to be solved. But fundamentally, again, this is a very important step towards robotics. I think it's exciting. I think we can see how this field is moving forward. And I think it's also important for our listeners. The purpose of this podcast is to give people a sense of what it feels like to run a hedge fund. And what we're doing here is really trying to gather enough knowledge on the science side to see whether the science side is ready for technology and the technology is ready for entrepreneurship. And I think we see that Venn diagram actually combine into a wealth creating future for our investments, in particular in NVIDIA and Tesla. Tesla has applications such as self-driving and Optimus, and NVIDIA is going to provide the compute platform which is necessary for these types of technologies. Thank you.